Hello students, we'll move on to our next examples on permutation. So we have seen two types, permutation of n different objects, and one is with conditions, right? So out of n objects, we pick R object. Okay, so here we move on to some more examples. Okay, let's say the first question. 7 students have been nominated to fill two positions in a class election. Okay, how many ways are there to fill the two positions? All right, so altogether you've got 7 students who are actually needed to fill two positions. So in this case, 7 here stands for your N and 2 is your R, means I've got 7, I only pick 2. Okay, so your number of ways, okay, will be 7p2. So this will be 7 factorial, 7 minus 2 factorial. 7 factorial over 5 factorial. So if you use your calculator, so it's 7p5. Okay, so you get about 2520. Okay, just check again. Okay, so another method of actually doing this, if you are actually using the ratio method, so this is actually if you're following the multiplication rule, so this is 5, 4, 3, 2 and 1. Okay, over, this is 5 factorial, means it's 5 times 4 times 3 times 2 times 1. Okay, so all of this and all of this can be cancelled off, so leaving behind 42. Okay, so total number of ways will be 42 ways of selecting 7 people to fill 2 positions. All right, okay, we move on to the next one. Okay, permutation of n different objects for given conditions. Okay, here, of course, you've got n different objects. And how many we pick depends on the question, but what is extra here is there is a condition to the question on how we want the arrangements to be. Yeah? So here, okay, how many 4-digit odd numbers, so my condition is odd numbered, can be formed by using the digits 2, 4, 7 and 8 without repetition. Okay, so if you want a 4-digit number, okay, so the condition is if you want an odd number, usually what happens is the last digit must be an odd number. So out of 2, 4, 7 and 8, 7 looks like an odd number. So that means here the choice is fixed, it is 7. Okay, so that means here you have actually one choice. So if you've already picked one here, so here I've got 1, 2, 3. So out of 3 numbers which are left, which is 2, 4 and 8, we randomly arrange them in any order. So this becomes 3, pick 3. Okay, times, this is one choice. Okay, so that means the number of ways would be 3p3 times 1. The 1 is here, and just to show you that the fourth placing, there's only one choice, one way of actually arranging it. So 3p3 gives you 6 times 1 is 6. So you've got 6 different ways of arrangement. All right, okay, let's have a take one more example. This question, okay, you have got 5 different books are to be arranged, okay, in a row on a shelf. Here I've got 5. All right. Okay, the history book is placed on either side, either end of the row. Find the number of different arrangements, okay, of the books. So meaning I've got 5 books. So 1, 2, 3, 4, 5. Okay, on a shelf. So you have got your history can be here, or history can be here. So they say either end. So if this is going to be history, these are 4 different books that you can pick from. Or let's say the history is here at the beginning. So this will be 4 different books that you can actually pick from. Okay, so you've got this way of arrangement or this way of arrangement. So if the history book is at the end, this is one way. The history book is at the beginning, this is another way. So that means the number of ways for arrangement. Okay, yeah? So the history either here or here. So I've got two factorial ways of arranging the history book. Okay, times altogether 5 books. So 1 is already taken. So remaining I should have 4 books. So it's 4P4. Out of 4 we pick 4 lah. Okay. 2, why? Because you can have the history book here at the end, or you can have the history book at the beginning. Okay. So for this is 2 factorial. So we actually use your calculator. So it's 4. Okay, so this is 2, and this becomes 24. So that gives you about 48 different ways of actually arranging the books. All right. Okay, one more question. Okay, how many ways? 5-digit. How many 5-digit odd numbers can be formed using the digits 2, 3, 5, 7, and 8 without any digit being repeated? Okay, so similar to the question just now, you've got 5-digit. So I make 5 spaces. So you've got 2, 3, 5, 7, and 8. So in order to get an odd number, that's my condition, the last digit must be an odd number. So you can actually have choices from 3, 5, or 7. 3, 5, or 7. Let me see, I've got 3 choices already. Alright, so at any one time, one number is picked, meaning for this 4 places, you actually have 4 different digits. So that means out of 4, we pick 4 digits. Okay, multiplied by, this last slot here can be placed, you can fill up with 1, 2, or 3 digits, okay, which are actually odd numbers. So therefore your number of ways of arrangement, so this will be 4P4 multiplied by 3 ways of arrangement lah. Okay, all right, so this one will be okay, so we get about 72. Sorry, so this is 3 factorial, sorry, so it's 24, this is 24 just now. Okay, times here I've got 3 different ways of arrangement. Okay, so times, so this will be 144 different way of arrangement. All right, so this is be this is another method of actually doing the question. All right, of permutation with condition. All right, thank you.